Okay, everybody, we are now at the last part of 2.2, and this will be the last video we do before we're ready to put everything together for the chapter test. Okay, this is going to be short and sweet. All this section is about a new vocabulary word called cofunctions. We've already heard the word coterminal, so we know the prefix co means to work together. Cofunctions are two of the trig functions that work together. Now, the hard part about this is you guys get confused with cofunctions and reciprocal functions. We've already discussed who's the reciprocal of sine, cosecant. Who's the reciprocal of cosine, secant. Who's the reciprocal of tangent, cotangent. And the reason why they're reciprocals is you take their definition, y over r, x over r, y over x, and you flip those fractions, you get the other three definitions. Cofunctions are not the same pairing up. Cofunctions mean they each have the word co in front of them. So the cofunction to sine is cosine. The cofunction to secant is cosecant. The cofunction to tangent is cotangent. So the reason why they're called cofunctions is if you put the prefix co in front of the word, they pair up. So sine goes with cosine, secant goes with cosecant, tangent goes with cotangent. Now what happens is cofunctions have a special relationship. And the relationship is two things. The first thing is the relationship is their angles are complementary, which means their two angles would add up to 90 degrees. When you evaluate them, their values will be the same. So, for example, I have in 4a the function cosine of 87 degrees. Its cofunction. Who's the cofunction with cosine? Well, if you take the word co off, its cofunction would be sine. And the deal is their two angles are complementary, which means their angles would add to 90 degrees. So what would you add to 87 degrees to make 90 degrees? You would add 3 degrees. What we're going to learn later on is when we learn to type this in a calculator, because right now we don't know how to look this up. We don't have an 87-degree triangle to look at. We don't have a 3-degree right triangle to look at. These are not quadrantal angles that we can look on the unit circle. We're going to need to learn how to look these up on our calculator in the next chapter. But when we look up the value of cosine of 87 degrees and we look up the value of sine of 3 degrees, those two fraction values are going to be the same. Okay, so cofunctions, that's why they're cofunctions. They have the word co in them. Their angles are complementary. They add to 90 degrees. When we look up their values will be the same. Now look at 4c. This is the tangent of pi over 12. What units is that in? Radians. What can you change it into? Degrees. So if we do that, pi stands for how many degrees, y'all? 180. What's 180 divided by 12? 15 degrees, right? If this is tangent and I ask for its cofunction, who is the cofunction with tangent? Well, it would be, cotangent, right? If that angle's 15 degrees, what would this angle be? They're not going to be the same. They're going to be complementary, which means they add to how many degrees? 90. So what do you add to 15 degrees to make 90? That would be 75 degrees. But here's the problem. If the original expression was given with the angle in radian measure, do you think you can give the cofunction in degrees? No. You also have to give it in radian measure. So now we got to change this to radian measure. How do you change 75 degrees to radian measure? You would multiply by pi over 180, correct? If this radian measure has the pi symbol in it, then the cofunction's radian measure will have the pi symbol in it. But I'm not going to leave 75 over 180 because they both can be divided by a common factor. Well, I believe if you end in a 5 and a 0, can't you divide by 5? So let's divide 75 by 5. and that'll give me 15. Let's divide 180 by 5, and that would be, let's see, 36. But 15 and 36 have a common factor, I believe, of, what would that be? 3. So we divide that by 3, we get 5. And we divide that by 3, we get 12. So we can't leave it as cotangent of 75 degrees. We'd have to write it as 5 pi over 12. Now that's the way most of you would approach it. You would change radians into degrees. Then you would figure out what I have to add to 15 to make 90, and then you would change it back. That's an awful lot of work. Why couldn't you just, from radians, change it into radians? So what does complementary mean? They have to add to what? 90 degrees, right? So when you found this 75, didn't you say 90 minus 15? Well, why couldn't we do this? Why couldn't we say, okay, this is pi over 12. If I want to find its cofunction, I got to subtract this from 90 degrees. What's 90 degrees in radian measure? 90 degrees in radian measure, I change it to radians. Well, 90 would go into 180 twice. Wouldn't that be pi over 2? And from pi over 2, I want to subtract pi over 12. If cofunctions, the angle's got to add to 90. That's 90 degrees in radian measure. Well, if I subtract that angle, I should get this angle. To subtract, what do I need? Hey, a common denominator, which happens to be 12. 2 becomes a 12 by multiplying by 6. There's 6 pi. That stays pi. Isn't 6 pi minus 1 pi 5 pi? So it doesn't matter to me which way you approach it. If you want to do the middleman by changing radians into degrees and then changing the degrees back to radians to get the cofunction angle, that's fine. But you don't have to. You could subtract that from radians if you understand that radian measure 90 is pi over 2. All right, the last example, 5b. It says solve for the unknown. Now, instead of using theta, which we've been using, I want to start getting you used to other symbols that represent missing angles in trig. This is the Greek letter beta. It looks like the fish. So that's beta. Okay? So we get, no, I lied. That's not beta. That's alpha, Miss Black. That's alpha, guys. The fish is alpha. So if I wanted to solve, okay, what do you notice about this function and this function? Well, tangent and cotangent are cofunctions of each other. And cofunctions means these angle measurements are complementary. Complementary means these angle measurements have to add to 90. So I'm going to take that angle, 3 alpha plus 4 degrees, and add it to 5 alpha minus 10 degrees. And that, I know, has got to add to 90 degrees. I can drop the parentheses because there's an invisible 1 in front. So 3 alpha plus 4 degrees plus 5 alpha minus 10 degrees equals 90 degrees. And now it becomes a simple linear equation. 3 alpha plus 5 alpha is 8 alpha. 4 minus 10 is negative 6 equals 90 degrees. Add 6. 8 alpha equals 96 degrees. Divide by 8. And alpha had to be 12 degrees. I'll prove to you we're right. Let's go substitute. If we put 12 degrees in here, 3 times 12 is 36. 36 plus 4, this is the tangent of 40 degrees. If that's 40 degrees, this better come out to be 50 degrees. If they're cofunctions, their angles add to 90. 5 times 12 is 60. 60 minus 10 is 50. So it did balance, it did check. So that last bit here on 2.2 was just introducing to a new word, cofunction. Cofunction does not mean the same thing as coterminal. Cofunction means two functions whose angles are complementary, add to 90 degrees. Alrighty, we are now finished with the whole first part of trigonometry, which was the study of angles. We are now ready to take a chapter test. I wish you the best of luck of studying. Go over your notes, memorize all your definitions and facts. Take your time, go slow, relax. I'll catch you in the next chapter.